I'm hi everyone, my name is Emilio, and today we're gonna learn about the periodic trends. Get ready for some science, yo. Okay, so first topic we're gonna learn about is atoms and their ionization energy. Let's go. Oh hey, didn't see you there. Let's learn a little bit about an atom first. And let's draw one here. Right here is the nucleus, and this is a Bohr diagram. Protons are the positive. So we're gonna use green because we're too poor to afford. We're too poor to afford red. Yeah. So this atom has three of these protons right here. They're gonna be shown as green. Then we also have neutrons. They're gonna be shown as blue. Now remember, children, that the blue ones are neutrons. Neutrons are no charge. Okay? And then the protons, which are green because we're too poor to afford red, the protons are they have a positive charge.
What are you doing?
This is not part of the diagram. You need to show that. You need to show that. You don't need to. Okay. All right. Back to the topic here. Looking back at this atom, this is gonna have 1, 2, 3 electrons because typically atoms have the same amount of electrons as they do have protons. Now the black ones are gonna represent the electrons. And remember, children, electrons always have a negative charge. Alright, now, knowing what you know about atoms, let's talk about ionization. Baby! Science. Oh hey, I didn't see you there. Today, we're gonna look a little bit more into ionization energy. But first, what is a periodic trend? Here it is. A periodic trend is a pattern of change that shows across the periodic tablet. For those of you,
Are you sure it's the top? I think it's the
Shut!
top.
Okay, all right. Well, hope that takes care of that. Moving on. Looking at some of the consistent trends, let's look at ionization energy itself. So, what is ionization energy exactly?
Well, we studied this time,
We
figured it out. Alright, so...
We know exactly what we're doing. Okay, ionization energy is the amount of energy needed to lose an electron. Just like here, when you're a babysitter and you're taking care of this fetus here, hi fetus, and then later on the fetus decides to leave and you're like, no, and it says, Ayla, now I must go. That's exactly how it goes. So, applying that to atoms, we can see how the more ionization energy you have, the more control you have over your electrons, like in this diagram. It's not going to hold onto its electrons, and it's going to say bye-bye. So where exactly do we see this trend on the periodic table? Going across it. Just right here. Going across. Let's go get another periodic table. We're gonna... But actually looking at the periodic table, we can see how there tends to be more ionization across the periodic table, just like in this diagram seen here. Let's go to the next segment. Alright, so where do we see this trend on the periodic table? We see it here going across left to right, increasing in ionization energy. And if we look this way, we see that going down, there's a decrease in energy. Here's a little bit why. Yeah, alright, so I just went to the store and picked up one of these red markers that we couldn't afford before. But here's the structure of the atom again. Now looking at the atom, there's protons and neutrons that are going to attract. They're going to want to attract the electrons. They're going to bring a force in. But here's the thing about ionization energy. Electrons present a problem with it. Looking back at this structure, we can see that the electrons orbit around very, very quickly. Since this is a Bohr diagram, you can't exactly see it. But little do they know that they repel each other from the nucleus. So think of it kind of like as a bar scene, okay? Let's think of it this way. This is Billy here, and Billy represents a proton, and this is Barbara, and Barbara represents an electron. He's trying to attract Barbara, and this is Bobby. Bobby is trying to attract Betty, and Betty is an electron, and he's also a neutron, so yeah. But look, the thing about Betty and Barbara is that they don't like each other, so they repel each other, just like the electrons repel each other. When you go to the table, you see another trend, an increase in electronegativity going from left to right, and a decrease in electronegativity going up and down. But you also see something that's intriguing, a decrease in radii going left to right, and an increase in radii going up and down. So why is this? Let's look at this atom that I drew. But if you look at it, electrons, remember, repel each other from touching the protons and the neutrons. So that means that the more electrons they have, the more they will repel each other, the bigger the radii. And that, kids, concludes our video. If you like it,